Since we already made a little noise, I think we can actually start. Good afternoon and welcome again to the Data Science Seminar from the University of Washington eScience Institute. Joining us today is Dr. Abraham Flaxman, Associate Professor of Health Metrics Sciences at the Institute for Health Metrics and Evaluation at the University of Washington. He's currently developing a simulation platform to derive what-if results from global burden of disease estimates, and is engaged in software engineering and development for verbal autopsy and probabilistic record linkage. Dr. Flaxman has previously designed software tools such as DisMod-MR that the Institute for Health Metrics and Evaluation uses to estimate the global burden of disease. And also the BedNet stock and flow model, which has produced estimates of insecticide-treated net coverage in sub-Saharan Africa. I'm happy to host Abe today, and his title today is Introducing Pseudopeople, census-scale simulated data for entity resolution. As usual, please use the Q&A button at the bottom of the screen to ask Abby any questions you may have. And as part of the University of Washington, we acknowledge the Coast Salish peoples of this land, the land which touches the shared waters of all tribes and bands within the Suquamish, Tulalip, and Muckleshoot nations. And with that, I will hand it over to you, Abby. Thank you.
Great. Thanks, everyone, for being here. I'm so excited to tell you about Pseudopeople, a project that my colleagues and I have been working on for about a year now. We've had a nice land acknowledgement, so let me follow it up with some disclosures, a custom in the School of Medicine where I sit. Most relevant from this grant research and other support is that the Census Bureau is a supporter of my research, and especially of the research I'm going to be telling you about in this seminar. In particular, we are a priority 2 cooperative agreement with the Census Bureau to improve entity resolution technology. And the part of that agreement that I'm going to be focused on today is this part number 1, where we said we would help develop a sandbox of large-scale public domain validation databases that replicate the complexity seen in real applications of PRL. If PRL is a term of art that you're not familiar with, don't worry, it's not that complicated. I'll tell you in a few slides. But the Census Bureau also has some disclaimers that they like at the beginning of talks. And so let me just give you those quickly before I dive in. First of all, this presentation is the views and opinions of myself, my views alone, and do not necessarily represent those of the US Census Bureau. And I am not representing or acting as an agent of the Census Bureau in any official capacity. And this we will come back to, the slides that I'm going to show you do not contain sensitive information. This is sort of Census Bureau jargon for the specific laws that I would be breaking if I showed you certain information. But this term of art, controlled unclassified information, CUI, is not going to be showing up on any of the subsequent slides, even if it looks like it does. I'm going to show you slides where I say, here's a name and an address and a social security number. Those are not real names, addresses, or social security numbers. All of that is simulated. And I know my simulation is going well when it starts making Census Bureau alarm bells go off saying, hey, did you share something you weren't supposed to share? No, these slides do not contain that sensitive information. They just are made to look like they do. So here's the outline of what I want to tell you about. And I'm gonna spend, I don't know, less than an hour doing it so that we've got some time for questions and answers, and put those in as we go, because I've asked Nicoletta to jump in and ask questions if there are ones that we shouldn't wait to the end for. Oh, if only we were face to face, then I could see the questioning looks on your faces and pause to let you ask a question. As it is, we'll do the best simulation of that as we can over Zoom. So what I'm going to tell you about is first introduction. What do I mean when I say simulated data? And very importantly, for the specific use that I'm imagining for this simulated data, what do I mean when I say probabilistic record linkage or entity resolution? Then, God willing, we will have a successful live demo showing you the pseudopeople package to use this simulated data, followed by some key features in the public beta release of pseudopeople that you could use right now. I'll then talk about some of the limitations in future work and wrap things up, as I was saying, hopefully with plenty of time for Q&A. Sound good? In that case, on to our introduction. When I say entity resolution, I'm talking about a specific kind of universe of computational and statistical challenge of linking databases. But linking databases when there's not a unique key on which to join them. So I can't see your faces, but I imagine we've attracted some computer science researchers who specialize in databases, know everything there is to know about how to do a merge when you have a unique key. Here's an example of the kind of data I'm thinking of where, oh, I wish we had a unique key on which to merge, but instead we've got things like last names, given names, date of births, and were it not for the way people have nicknames or misspellings of names or transposed numbers in their dates of births, we would be able to use this as a pretty unique key. But because of the way that there are certain errors in the data, there's a lot of additional work that has to go into it. And when we work with Census Bureau, you know, the way I think about things because of the public health, global health, health metrics side of things I do, I'm often thinking about the entities I'm trying to resolve as people. And Census Bureau might have, say, a list of 300 million people that they gathered through great labor for the 2020 decennial census. And they want to match that up with something. But they're also interested when entities are households or businesses or even establishments, getting at something between kind of businesses and places of business. And so I just put that out there to give you a range of ideas about the different kinds of entities that we might be interested in resolving. The reason I'm interested in this is because of the way it can really help out when we want to do health research, but we don't want to do the work that the epidemiology department is so expert in collecting the data necessary for that research. For example, this has been really successful in illicit drug epidemiology. Here's a quote from a thesis on a specific way of finding out how opioid substitution treatment in prison is going to reduce recidivism, reduce mortality. There they used administrative data to link together, you know, data set A might be about people who have been through the criminal justice system and have or have not received opioid substitution therapy. Data set B might be data about mortality or about future involvement with the court system that could help us understand the effects of this treatment. And because these different administrative data sets already exist, there's an opportunity to find things out without the expensive, time-consuming, really hard work of coming up with this data originally. This is, by the way, something I'm so excited to bring to the eScience Institute, because if you think back to like coining the term eScience, this is so central to what I think some of the original, you know, fourth paradigm kind of thinkers were saying, that like the data is out there. Maybe they were more interested in the natural sciences. This is coming up more in social and health sciences. But in so many ways, we're generating data like this all the time as our sort of digital exhaust. And if we can figure out how to link it up and how to use it, oh, the things we can do. Now, when we take a step back and say, okay, we're not talking about opioid substitution therapy. We're not talking about any specific application of record linkage. In this talk, we're sort of talking about the technology for doing record linkage and entity resolution, but taking a step back even further, we're talking about simulating data to help in developing methods for then eventually being able to do this research. So it is a little bit niche. My hope in talking to you is that, first of all, I find some people who are in this niche, and secondly, I interest some people who maybe didn't know before this that they were interested in this niche. But third, that I find other uses for this simulated data because we made it specifically for doing entity resolution research, specifically at census scale, but I think it's going to be good for other things too. Maybe as we're going, you'll think of one of those things. In the context of census scale entity resolution, there's sort of a hypothesis behind developing these testbed data sets. The hypothesis is that the private and confidential nature of the data necessary for this sort of entity resolution has been a barrier to the research and development of entity resolution methods and software. And so if you think about it this way, I'm sort of doing an experiment on the algorithms developers by making this data. The experiment is to simulate this massive noisy data set and put it out there so that people can use it and see if it sparks more innovation in entity resolution research and development. Now, I'm not really like doing a untested scientific study on human subjects when I do this. This is just kind of a way of thinking about what I'm doing. So, you know, as I give more of these talks and see how it goes over with the research community, perhaps I'll be able to come back and informally tell you whether the result of this was to confirm or refute this hypothesis. But going in, I can tell you that there's some evidence that supports this beyond just like it makes sense to me. For example, as soon as Census Bureau wrote that they were awarding these contracts, they put a brief snippet on their webpage about it, and researchers started coming out of the woodwork saying that they would love to have this data. This is someone who a year ago reached out to say, I'm doing record linkages at University of Miami. I would love to test these data sets. Let me know when they're ready. He is using it and the test is going well. And hopefully it's going to be some additional evidence that we're on the right track making this simulated data. Another reason I think there's a need for this validation data is looking through the literature. And so when people develop new methods for entity resolution, record linkage, or even just new software codes, they often write up some of their findings showing that their new method has some benefits. Here's a typical figure from that sort of research from a political science researcher, Professor Innamorato, who's written a very nice kind of like introduction to probabilistic record linkage. This primer can get anyone up to speed if they want to see how it works and come out saying his approach, which is an R package called FastLink, is pretty awesome. He's compared it to a previously existing R package called record linkage and shown that in terms of the time it takes to do this linkage, his is awesome. FastLink is taking just a few hours to link 200,000 records, while record linkage is like off the charts hours, even for 50,000 records. The thing is, Census Bureau has a lot more data that they need to link than what political scientists are interested in when it comes to a large data set collected from, say, voters in a particular district that they're studying in their research. And so another reason for building these specific testbed databases is to maybe, hopefully, nudge people who are doing this research towards the sort of size and scale of challenges that Census Bureau is faced with. And just as I was preparing this talk, there was an interesting back and forth on the FastLink's GitHub page, where someone who's using this said, hey, by the way, this is awesome. I'm having a little problem with it. And so very technically in the details about what the EM algorithm, blah, blah, blah. But unfortunately, this is the part relevant to the simulated data, this user's data is not shareable. So I can't exactly tell you how to reproduce this problem, but here's some details of it. And then they give some details, and they were able to get some back and forth over the course of a year to get some feedback about how they might make things work better. Another way to look at this hypothesis about the value of this simulated data is that it's going to speed this up. Instead of having this back and forth to try to hint at where things are in the data, we're going to be able to say, and now, although we can't share the real data we're working with, here's some simulated data that basically seems to capture the same problem we're having with our real data. another slide getting at the sort of scale that census data runs into. I kind of alluded to this already, but from a careful study of how the 2010 census matched things between the millions of records collected going door to door with the other millions of records available in the sort of digital administrative data coming from, say, tax filings or social security claims, or all sorts of things, the postal service. We're not in the thousands or tens or even hundreds of thousands of range like we had on the last slide. We're in the hundreds of millions, or even once you've done the easy stuff, still in the tens and 30s of millions of records that we need to link. Not to belabor that point, I want to get through the introduction and start showing you some of the simulated data I'm so excited about. But it's important for me to note that I'm not the first person to be doing this ever. And there are approaches to validation data that are very much in line with the way that I'm going to be telling you I've been doing things. Australian National University over a decade ago was already working in this direction with Python code that is still available. You can download it now from their SourceForge, but it is getting a little out of date and you have to use Python 2 to run it. And we thought, we could go beyond what's out there. In part going beyond it, using some of the ideas in one of the other subsequent approaches called the synthetic occupancy generator that, as opposed to the Febril/Gecko approach from Australia that sort of looks at a snapshot of simulated data, the synthetic occupancy generator approach looks a little bit more over time, simulating what's happening with the individuals that are going to be represented here. So you can look at how people move around. And besides these two really notable ones, there are other simulated data efforts by other groups, often sort of tucked into work that they've done developing new methods for entity resolution, where they've then invented some simulation approach to test particular aspects of their new method and see how it compares to previous existing methods. And besides this simulation approach, there's other interesting alternative directions, like using real data that's available from open sources, such as the voter registration data that was behind that slide showing how fast FastLink is. There's even a group at University of Michigan that's been putting together a library of data that you might want to test linkage on, the linkage library. And then there's a group at the English version of this, the United Kingdom's Ministry of Justice is kind of where that research is happening in the UK. And they've come up with a way to generate test data by crawls of Wikipedia, where they can get millions of records that have, real world noise in them. And they actually don't make that data available. We'll circle back to some of the ethical questions about what we share from all of this towards the end of the talk. But they make available all of the code necessary to reproduce their creation of this real data from open sources. And if you ask them really nicely, maybe they'd share the results of that code with you, but they don't want that to be openly available, basically because of how creepy it looks for some government agency to be crawling the web and creating lists of people, including their birth dates and addresses. So the simulation that we have used to make this is something that I probably should go into more detail of, but I'm so excited about the application of it that I'm just gonna circle back to that if you want questions about it. In short, you heard maybe in the brief intro that the focus of much of my research is on simulation modeling, and we have a simulation framework called Vivarium that typically we use for answering what-if questions, but in this work, and I'm really excited to continue now, we've also used for generating simulated data. I think that in addition to this entity resolution stuff, there's tons of opportunities for simulated data in machine learning and general artificial intelligence applications. Looking forward to more of that in the future. But in this case, we've brought together sort of data from the American Community Survey and other data sources, and some of the typical stuff that we do in our Vivarium simulation models, like demographics about mortality, fertility, with some extra special stuff really relevant to the census data, migration, household structure, employment, business dynamics, and layered on top of all of that, what we call observers that are basically simulations of doing surveys or decennial censuses or just the kind of administrative records that happen through people getting social security numbers, or say being on WIC social services. And if you want to learn more about all of that, we have in way too much information, the details of it, that our researchers write to share with our software engineers so that this can all be implemented in a simulation. You can see this concept model doc that doesn't have a nice URL, but in the Vivarium research repository. I'll help you find it if you can't find it, if you want to find it, with lots and lots of those details. And so now, without further ado, the part that I have been so excited to tell you about, but I felt like I needed to give you a little bit of background so you could understand why I'm excited, is a Python package to use this simulated data, *pseudopeople. And this is a Python package that generates realistic simulated data about a fictional United States population that I want Census Bureau and other entity resolution researchers to use in testing record linkage methods. And I want you to use, maybe because you're also interested in this record linkage and entity resolution stuff, maybe because you have some other use for it. If you're working with people, maybe this people data could be for you. It's simulated. So as I mentioned at the beginning, it's going to look like there's confidential information here, but it's not. No need to worry about confidentiality. It's versatile. We've got multiple data sets about the same population, censuses, surveys, administrative records, and it's verifiable. So now this is one way that it goes beyond the path of finding real world data to test on. Because of the simulation, knowing who's who in some ground truth sort of way, there are unique identifiers present in all of these simulated data sets. Don't use these to link on, use it after you've linked to check how well you did. And it's customizable. I'll show you in a few secs how to configure the level of noise in the data sets you're simulating. And I'll show you how to get it up to full scale, because this supports generating data sets at the size of the real life US population. Database researchers, people interested in the computational challenges of this stuff, I hope I've gotten some of you into the room for this, because it is kind of a pain to work with data representing 300 million people. I don't know if it's appropriate to call it massive data or big data, but it's certainly medium data. You certainly are going to be waiting a long time if you're not careful about how you do things with it. So now it is time for me to demo. And I've got this slide of notes about the outline for this demo. But if you want to follow along on your own, the important note here is I'm going to do it using Google Colab, so that people who don't have Python set up and still want to try it out have an easy way to try it. Go to colab.research.google.com if you want to do what I want to do. If you haven't used this thing before, this is an awesome resource. I'm just going to create a new notebook, and here I am with an interactive Python notebook. Hopefully it's big enough for you to see, and I can pip install *pseudopeople to get this Python to have our package. Hope it works. I hope it works quickly, because I want to demo it all. And I'll know it's worked if that little spinny thing stops spinning and it doesn't complain about anything. Yeah, not too bad. 11 seconds. So now to see if it works, I'm going to import *pseudopeople. And there's just sort of a Python custom. If you're not familiar with Python, I'm going to call it as PSP. So then I can refer to it as PSP and not have to type out the whole thing, *pseudopeople, all the time. And so now I have installed and imported *pseudopeople, and I'm ready to generate, what should we do? A decennial census. Seems like the right place to start if I'm working on something for Census Bureau. Shift-Enter, I haven't said, but is the key combination that I'm using to execute these things. And if you don't like doing that, you can just click on the play button. And there we go. What I have installed and downloaded is ready to go with some sort of small example data saying, okay, as a simulated data set for starters, here's roughly 10,000 people that you might find in a decennial census. They've got first, middle, and last names, ages, date of births. And in this small data that we start with when you just first install it, they're all in a fictitious place, Anytown, USA. Now, if you never use Python and you don't want to use Python any more than you have to, if you just say that you want to save this to a CSV, you can do it that way and go use the simulated data in whatever it is that you like using it in, R, Stata, SAS, whatever. I want this to be something that works for everyone. At this point, it takes a tiny bit of Python to get it to work. And I have an impression that East Science Institute is kind of a Python shop. So I think we're in okay shape with this audience doing it this way. Now, what I want to point out is there are plenty of options here. And one important one is what year we're going to generate a decennial census for. The default, when I said nothing about it in the line above, was to generate decennial census for 2020. But how about if I want one for 2030? Well, all it takes to do that is say year equals 2030, and then execute that cell. And then we've got a simulated decennial census for the next decade. I'm going to copy that and do it again, because I just want to note down some of the people here, like Sharon T. Schmidt, age 69, in the 2030 census. If I've remembered correctly what's happening, she is also going to be easily visible in the data that comes back from a 2040 census, but 10 years older. And in this simulation that's backing this, people are moving around. Sharon, it turns out, if we had gone up and looked, I believe has not moved and has been at 107 Stallion Drive this whole time. One of the reasons why I think it's important to have a Python package for this and not just a bunch of CSV files, which is often the way our simulations end up giving results, is because it is very interesting, for me at least, to be able to configure things about how much noise we have in these simulations. And so eye on the clock, I can't do every fun thing that's out there in the simulation, but I do want to do a little bit of configuring. And unfortunately, the configuring is a little complicated because there's a ton of configuration options. So whenever I do this, I spend a second going to the pseudopeople docs at pseudopeoplereadthedocs.io, where I think if I go to a tutorial about configuring noise, there's just a little block of code that I want to copy in there. And it says, okay, here's a ready to use dictionary. It's going to have some way of changing how much fake name probability there is for last names. The only thing is that example was about the current population survey, and I want to do one about the decennial census. And I want to have a lot of fake names, just so it's pretty obvious. So I'm going to change this to a 0.8. Then I don't have a copy and paste error. I'm optimistic that we'll see a lot of weird names in here, like Madeline A. Adult or Stephen R. Friend, based on the kinds of fake names that really do creep into census data in practice, although certainly not 90% of the time. One of the things that I can't show you easily in this demo, and we'll circle back to why when I start talking about some of the kind of moral dilemmas and ethical choices in this design, is going from this 10,000, 11,000 rows to a full scale USA version. And so instead, I'm going to switch now to one that's running on one of the IHME computers with a lot of memory and show you how, if I've downloaded a pretty big file of pseudopeople input data, this is 23 gigs of data to do a full-scale version of Rhode Island. But this folder is based on 400 gigs of data to do a pseudopeople full-scale run of the whole USA. And then do that stuff I did before, import pseudopeople. And PSP generate a decennial census, but with a different source. Basically, the source being the folder for all of that input data. Then instead of quickly coming up with 10,000 rows of data, it will not super quickly come up with 300 million rows of data. And so I decided to do this kind of like sometimes on a cooking show. They say, now you put the cake in the oven, and then when we take it out, it looks like this. And in this one, oh, I did a different one. Okay, I'm a little bit off in my cake coming out of the oven. I first loaded a simulated data set based on the administrative data collected by WIC, Social Protection Program. And when the cake comes out of the oven, we've got this multi-million row set of data that represents a sort of USA-sized set of WIC administrative data that you might use in testing your entity resolution algorithms. And then just for seeing how long things take, I did the next one, which would have been the better baking show if I had remembered which was which in the order, to say, okay, now let's do a full-scale USA census. The WIC one, it's just a little bit too slow. Like I think it takes 20 minutes to load it all. But this one took 90 minutes to load that. And once it's loaded, now you can see something that looks a lot like what we were looking at before, but instead of ending after 10,000 rows, now it ends after 300. 300. I'm having trouble saying this number. 331 million rows. And so then you could say, do a deterministic merge on the simulant ID. This isn't probabilistic record linkage. This is just comparing what's happening in WIC data and decennial data and come up with a merge data frame. And none of this is fast enough to do for fun in a demo, but with all of the millions of rows that are present in WIC and in census that represent both the first name as it appears in WIC and date of birth as it appears in WIC, and similarly in census, which is just the kind of thing also that I think is going to be useful for people who are developing and testing new sorts of probabilistic record linkage and entity resolution. And then I didn't have the courage to see how fast working with 500 million rows of data is, but I did ahead of time say, okay, in the decennial census, because we know that we should simulate some noise in it by default, the default noise has a missing first name in the decennial census just in 4% of the data there. I'm kind of curious how long it takes to do that. Not very long at all. And so based on the amount of time that I have to talk to you all today and the amount of time that I'm trying to reserve in case there are questions later, I think this is the perfect place to wrap up my demo and return to telling you a little bit more in a structured way about what's in this pseudopeople package. Again, questions, throw them into the Q&A, and Nicoletta is going to jump in if any question seems like a great one to answer during this talk. Otherwise, I'll save some more time also for them at the end. So the place that we're at now is basically validating this against the noise that's found in real world data. And we've got a great collaboration going with the Washington State Department of Social and Health Services that in their own routine work does a lot of this kind of linkage so that they can tell us, well, here's what it looked like for you, but here's what it looks like for us. For example, in their case, when they're looking at basically linking data about people who are receiving social services in Washington state, they ask for social security numbers, but they don't often get them. So in about 75 people out of 100 who are in their database don't give them a social security number to match. But 20 out of 100 do give it to them and give it to them right. And then of that remaining 5, 4 of them are just wrong on 1 digit. Like maybe it was a typo when they were typing it in, keyboarding it in, or maybe it was a sloppy handwriting if it was written with pencil and paper and then had to be transcribed. And it's quite rare for things to be very wrong in a social security number if it's provided in this DSHS data. How does that compare to our simulated data? And something we'll return to later, what more realistic parts of that comparison should we focus on, because it's going to be important for this kind of entity resolution work or for any use of this data going forwards. So that is the conclusion and reflection on the live demo. And now I'll tell you about some of the key features in this public beta release that perhaps you're already playing with in Colab right now, and then conclude with some limitations in future work. The key features are these generate X, where X is a census relevant data set. We focus mostly on decennial census, but I mentioned also that there's this WIC data, and some of the other data sets that we've got are like the American Communities Survey, Current Population Survey, some simulated Social Security data, simulated tax data. Maybe I should have led with the tax data, considering the potential interest in what's really large scale data, because tax data you get every year. So it's maybe not everyone who shows up in the decennial census files taxes. Kids don't, people who have no or low income don't. But if you're simulating over 20, 30 years, you have 20 or 30 years of those tens, hundreds of millions of people filing taxes compared to just 2 or 3 decennial censuses. And then on top of these simulated data sets, what's the one thing to call out? I guess the one thing to call out is that I've grayed out things on this list that I wanted to do, but we didn't actually get done in time. And so we've got basically simulated tax records to represent the W-2s and 1099s that would be like between an employer and an employee, but we have not finished simulating the part where individuals who have to file a tax return put that all together in this sort of simulated 1040. And so that's kind of an interesting additional challenge that'll be coming soon. And I mentioned on the previous slide all of these other data sets. But each of these data sets has a different subset of columns. And so this slide, I've tried to call out how, first name, middle initial, last name are pretty common. Age or date of birth might show up depending on the data source. And then there's a lot of information about geography. I've kind of summarized it here, but this might come up both either about like where someone's house is located or where their mail is received. And those things might be different. And then when we're looking at that sort of tax data and employment data, it might also be about where their employer is located. Interesting side note about confidentiality. Should I do this? Do I have time for it? The IRS says, there's Title 26 that governs what is confidential in terms of our tax data. And they hold that stuff so tightly that just knowing the schema for that data is considered confidential. So all of the tax data that I've been talking about is basically stuff that we just dreamed up looking at what goes on a 1040 or what goes on a 1099 or a W-2. And we haven't actually gone into the confidential data to see what really is in there, because once we've seen it, how are we going to unsee that to share something that you don't have to worry about confidentiality for? And then this final column is stuff that might show up in, either some of the tax data we're imagining or some of the administrative data, or just in some of the interesting complex data in census or the ACS, some of which might be useful for linking in the kind of person way that I think about, some of which might be useful for doing even more complex linkings and new experimental methods looking at, say, linking by households and household relationships. to go beyond what you can do just looking at individuals. And then layered on top of all of those different columns and all of those different simulated data sources are all of the different types of errors you can have, different ways of things going wrong, like just leaving it blank, to intentionally or unintentionally choosing the wrong option, to using the fake names that we looked at recently when I was demoing, or misreporting age because you don't remember or don't want to confess to your true age. Lots of work that some of my colleagues have done to really kind of capture some of the realistic ways that things can go wrong. A lot of these are grayed out for the current version, but actually on the develop branch of our Python package are really in there now. We might have all of these now. So coming soon, the pip installable default version. And if I've convinced you that this is something you might be interested in to play around with, to use in your own work, just to see how we've done it, you can learn more at pseudopeople.readthedocs.io. Now, as I've alluded to, I have a lot of different target audiences in mind for this. And this has been an interesting challenge, one which maybe you have questions or even just comments about, because I'm very interested in how this audience might approach it. I want it to be something that's useful for Python users, but also I want people who are not really preferring Python to also be able to use it. And I expect there to be a range of both levels of proficiency in analysis and levels of familiarity with using this kind of large-scale data among the people who want to use it. And so this is coming up in particular in designing some of the more helpful API around, like, what if you wanted to load this in a distributed compute environment? How do people want to do that? What sort of affordances should we provide to help them? This is just a little bit of a brag slide because I'm kind of proud of how much work the software engineers put into testing. Quality assurance has been a particular point of interest for us. And so we've got a QA approach where the researchers who developed the kind of concept model for how this should work are then looking at both the stuff coming out of the simulation, how it's being post-processed, and then how it's coming out of pseudopeople to make sure it misses their specification. But we also have this automatic testing that the engineers are doing based on their understanding of it. This is just a screenshot of a bunch of tests passing to help me brag on the cool amount of work that they've put into it. And the VMV strategy here, this is a simulation term of art, the verification and validation strategy here really relies on both the engineers automatically testing if there's sort of like code is doing what the researchers said it should do, but also the researchers sort of testing if what they said it should do is really what they meant it should do. And so getting into kind of the home stretch now, I want to just tell you about some of the limitations I see in what we've done so far and directions for future work. And this is a cool thing because Census Bureau allowed us to set this up so that we did one large bulk of work to get this out the door. But now we're going to use it for the next, I don't know, 6 months to a year. And hopefully they'll use it and you'll use it too. And based on all of the feedback and experience that we have using it, we've got another round of development really scheduled as part of this project to add things addressing these limitations as future work. Now, it's very easy to look at this and identify areas where there's a lack of realism, where it would be really fun to build in additional realism, and you can sort of flag these as limitations. Migration. Oh, I should have demoed longer, so I could have called out the way there's a lot of migration happening. When people move households, they're often moving jobs as well, and there's an effort to kind of capture this hard part of linking that if you know where someone was living last year, that might or might not help you find who they are in some administrative data source this year. But there's a lack of realism in our migration. We could go very deep into adding realism there. And then the important trade-off question is, how deep should we go in terms of making this fit for use, developing entity resolution algorithms, versus how deep would we go if we just could do as much work as we wanted, making a realistic simulation of migration? because we can only make it as realistic as seems justified. Name changes, another great example. One very hard thing about doing this fuzzy matching when we were linking on names is that people change their names for a range of reasons. Marriage being an important one, which, by the way, might be coupled with migration, or at least changing official addresses. And I'm sure there are tons of other ways that you have been wondering about, or maybe even using the demo, examining as I've been talking about this. Which ones shall we prioritize? That's one of the important limitations and questions for future research. But then there's another interesting limitation, which I think of as sort of the opposite of a lack of realism. And I also, in my own mind, think of this as sort of a creepiness. At national scale, there's probably someone in the audience who would find someone with their name, first, last, even middle initial, in this data. And some of you in the audience might have very common names and be familiar with lots of people sharing your name, but this 330 million names and addresses, even if you have a not too common name, somebody's going to find themselves in there. And it's still a simulated person. It's probably not going to have their right address. It's certainly not going to have their right social security number, but there's still a certain creepiness to this. And in addition to being very careful that we have used open data sources and not done anything that might risk intentionally including a real person, there's still a problem with the perceived inclusion of a real person. And so in addition to developing the sort of simulation and the sort of package to use the simulation data, but we've also in parallel been developing what I think of as an ethical framework for sharing synthetic data that looks creepy. I need a more technical way to say that, but that's the nuts and bolts of it. And so graduate student Os Keys from Human-Centered Design and Engineering has really led this work, and they say we should have a framework where we have transparent decision-making around data set design access, and this should include kind of the public, or at least advocacy groups representing the public involved in these decisions. I should have led with, they convinced me I can't do this perfectly. Even if I'm never using data that includes real people, there's still the perceived inclusion of real people, even if it's not a correct perception, that has risk of just as much harm as if it really had people information in it. And so in this framework that they've been developing, there's a sort of ongoing role for these advocacy groups representing the public in questions of data usage. And the goal in this is twofold, both to strengthen trust by the advocacy groups in how data users are working with this, and then also to build these sustained relationships between us as the data producers and these advocacy groups and the data users, researchers who are going to be working with this. There's kind of a whole story to be told about this, but it's really better for us to be the one to tell it. You should book them if you think this is something that would be fun to dive into in the future. And so in practice, what this looks like is if you want 10,000 rows of data, pip install pseudopeople, you got it. If you want 10 million rows of data, request access on the project GitHub page. And we're trying to make this lightweight so it doesn't require much information. You tell us the name and purpose of the project you want to use it for, who's involved in the project and who's going to really be working with this large-scale simulated data, and just a little bit more about who's funding the project and basically if there's any conflict we can anticipate about requirements for open access based on that funding. And so we're just getting started. I've given the first kind of public talk revealing this just 2 weeks ago, and we're just starting to have requests for large-scale data access come in. So this is a very newly being developed kind of part of the work that I think is really promising. If we can do this well, I think that there's a lot of risk from not doing this. And so if we don't have a catastrophe, we've done it well. And then bringing this just to a little bit more of the limitations, one thing that I don't know, and maybe actually this is a great audience to test on, is how are typical users going to work with this large scale data, be it 300 million rows of person data, 6 billion rows of simulated tax data. I have at my disposal a pretty nice computer cluster. So if I want to just spin up a distributed 16 terabytes of data to try loading it in the middle of the night, I can get away with that. But I'm sure that other people who are going to be working with this have other ways of doing it. And I'm kind of guessing that there are people in the audience who can really give me some good leads on both how people are doing this and how we might want to nudge people, especially if they're more from that less experience with large data, less experience with analysis kind of set of potential users, because maybe, you know, they're just realizing that they would really like to know how to load millions and billions of rows of data, would be very open to suggestions about a good way to do it. And so I think that brings me to the end of my slides. And I end with this invitation. Use it, pseudopeople. I hope it's useful. I hope you use it a little, use it a lot. Give us feedback if you use it, if you have thoughts about it. You can email me, ab@uw.edu, to give me feedback. You can create issues on our GitHub if you want to do it in a easy to track way. If you want to learn more by reading, go to pseudopeople.readthedocs.io. If you want to do more by diving in, here is the 3-line quick start. Pip install pseudopeople, import pseudopeople as PSP, and then get a data frame with PSP, generate something. That is it. Thank you so much.
All right, AB, thank you so much for your talk and for your demo. Sadly, we don't have too much time, but there are a few questions in the Q&A, and really, like everybody else, I was wondering if there is a pseudo Nicoletta with an undeclared age in your database. And so I think the two of the questions kind of refer to the same thing, and I'm just gonna read one that came up first from Jennifer. Could you say more about where the names come from? And I'm particularly curious about ways in which administrative systems don't always match with the names that don't follow an Anglo-Saxon pattern of first name, middle name, last name.
Yeah, great question. And that is a known major problem in doing this, known to people who have complex names, especially say, do you have a hyphenated last name or a last name with a space in it? But also known to people who do this kind of entity resolution and record linkage. And so our strategy in developing these names was to capture some of the real world complexity in it. And there are two really nice data sources that help us do this. One comes from the Social Security Administration that basically releases a baby names data set. So this captures what people are being named every year. And they've worked hard to protect privacy by saying, okay, really rare names we're not going to include in this, but names that are even just pretty rare, we're going to say every year how rare were they. They also include a sort of binary gender coding to say, this is how many boy names there were, this is how many girl names there were. That's where first names and middle names come from in this simulation. Last names come from a data product released by the Census Bureau based on the last names that they found when they were doing a decennial census. Again, with an approach that kind of limits what's in there so that the really rare last names are not included. And while first names from Social Security Administration just tell us about this binary gender variable and year, last names are only a snapshot at a certain time, but tell us also about race and ethnicity. And so we are in simulation able to get at some of these complexities, but also clearly miss others. And so there's a sort of one additional step to get at hyphens and spaces, knowing how important some of those are, where we've gone through voter registration data to see basically by race and ethnicity, how common is it to have hyphens or to have spaces in last names, and then added those hyphens and spaces. But going back to what's realistic and what's unrealistic, some clearly unrealistic pieces include like getting just part of the race and ethnicity right in very common ethnic names, because we're working with this sort of abbreviated census list of race and ethnicities. I think it's probably actually in here somewhere if I scroll over, that you can see that, you know, there's a 6 categories that don't capture nearly the complexity that's happening in our population and in our names.
Thank you. I'm gonna ask you, I'm gonna read a question from Jacob. He's curious if the backend of the pseudopeople package is written all in Python, and if so, has that led to any performance issues?
It is written all in Python, but it relies heavily on this sort of scientific Python stack. So I'd say we haven't tested it extensively. I can't say that, no, it hasn't led to performance issues. On the other hand, I think that it's more like if it was written in C, but still running with a single processor, it would take this same kind of 90 minutes to go through all of this data. And it's more, I think, about architecture than about language to get it to be responsive at this point. You know, when I did that distributed load that I was just basically bragging about how much memory I'm able to spin up on a distributed cluster, it was 20 minutes to load a decennial census instead of 90 minutes. And so it's definitely, I would say, worth exploring. And if you think that it's way faster to do it a different way, let's try. I would love to learn that I could do it in 90 seconds or 9 seconds instead of 90 minutes.
I think we're gonna get take one more question. And I hope, Raven, that the questions about names and the confidentiality have been addressed already. So I'm gonna read this one out. Do you also plan to add entity normalization or disambiguation in your data set? For example, if the same person is present twice with probably slight different names or initials or any other factor?
Yes, yes. So just the opposite. We want to make it hard by including that duplication so that people who are trying to remove it can sort of test if their method has been successful in removing it. I'm going to circle back to my slide about all of the different types of noise that we've included because I think that there's a term of art that we've made up for this one, duplicate row. And so this is grayed out because we don't have it yet, but there's a lot of interesting stuff that the researchers I'm working with have thought about specific ways that someone might show up twice that might, you know, be slightly different and a challenge for this kind of work. And like I was saying, these are grayed out because they're not available in the pip install pseudopeople version now, but I think this is in the develop branch on the GitHub at this point.
All right, since you did not find the pseudo Nicoletta in your database yet.
Oh, it was going so slow, wasn't it? Did we find any Nicolettas? Let's see. Yeah, I'll have to get back to you on it.
Okay. We're gonna wrap up here, and AB is gonna keep us posted about who is present or not in his database and how fast will that load in the future. And I'm hoping to host AB in the future to, you know, hear about updates from his package and future work. All right.